Hi everyone, my name is Dzmitry Bushenka. I work for Customer Times as a solution architect. Today I'm gonna discuss some issues which arise while documenting software requirements, functional or non-functional, whatever. I'm going to show you more or less common way it is done in software development companies. I believe you will definitely recognize this way, and then I'll highlight some issues which show up when you document the requirements this way. And then I'll try to discuss with you how to overcome those difficulties. I don't believe there are suitable tools on the market today, so one of my goals for this talk is to motivate the companies to start thinking the right way and to develop the next generation of requirements management tools. Okay, let's start. Long time ago, in 2007, I started my career in IT as a business analyst. I had to write a lot of those functional specifications, so I have some experience in documenting software. Sometime later, I turned to Java development, and now, as I've already mentioned, I work for Customer Times as an architect. I like to extract the requirements for the system, especially non-functional requirements. I like designing the architecture of the future solution. It is so amazing to solve the problems of balance when you have to find the cons which you can stand and the benefits you really need from the solution. All this architectural work is quite important for the project, but with one crucial condition. All those findings and the designs should be thoroughly documented. I think you will agree that without documenting the requirements and agreed solution, you will not be able to approve your vision with the customer. And also it will be so difficult to explain it to the developers and quality assurance engineers. So let us think a bit of this. Usually we have Confluence and Jira, which is really cool. Then you have those emails, Skype, WhatsApp, Teams, Discord and Slack discussions. And please don't forget the notes you have taken on the paper while discussing the next feature in the meeting room with the customer, manager and business analyst. And I swear you have forgotten those pictures on the whiteboard you have taken on your iPhone. There is no surprise everyone hates such documentation. When being onboarded to an ongoing project, I always ask for documentation, and almost always I hear the following: Dmitry, you understand? I don't want to understand anything. I want to see some requirements documented. I want to read about the architectural solution. I want to have it all up to date. Why the situation is that bad usually? The main thing I see here is that no one likes to write and support the documentation, especially developers. Everyone treats the documentation as some useless artifact which managers insist to create and just distract the developers from writing their code. In the history of software development, there were a couple of things which already survived this kind of treatment. I mean unit tests, of course. From the beginning, developers hated to write unit tests because they thought they would better write some source code more and implement more features instead of testing what was working already. Then the managers started asking for unit tests, and the developers just silently skipped this part of work. About 10 years ago, most of the companies agreed that the unit tests are mandatory, and the developers started writing those but hated doing that. The developers simply did not see any sense of writing the unit tests. Until some refactoring occurred, which ruined all their work, and with the passing time, developers understood that unit test is a tool which helps changing or fixing the code, allows understanding it better, and saves a lot of money in the end. Next step was that developers liked having good unit tests. Now we usually have continuous integration pipelines which run the unit tests automatically, check the unit test coverage, and insist on having most of the code tested. And everyone understands why is it so and what benefits we get. Similar situation is for documentation. As I've already said, no one likes to write the documentation because usually people don't see any value of it. This is why usually we have so poor documentation on the projects. I believe the time will pass and the thing will change. The goal of my talk is to highlight some technical problems which prevent us from loving the work to write the documentation. Would you agree that if something is technically hard, you probably will hate doing it, right? Let us see the documentation pain points we have today and what we probably could do with them. When I was just a developer, I didn't care in what form they gave me the requirements. It could be an 800 page brick size printed specification. It could be just a Skype call where they just told me do this and this. I didn't care because if the requirements were wrong, insufficient, often changed, inconsistent, whatever, that wasn't really my problem. Sometimes the requirements were so wrong or so inconsistent that I had to rewrite the code. Of course, that demanded much more time to finish the feature, but again, that was a paid time, so I didn't care. In other words, if I got wrong requirements and implemented them, then it was not me who had to pay for rewriting already written code. Now, when I am responsible for non-functional requirements and for the solution architecture which meets those requirements, I really care how to write those so that the developers will be able to implement them correctly from the beginning. I don't want to explain to my boss why the project came out of deadline. I don't want to persuade the customer that this is the last time when we exceeded the budget. This is why I'm so interested in writing clear, readable, correct and consistent tasks for my team. When I was working as a business analyst about 15 years ago, I used two tools for requirements management, Borland Calibre RM and IBM Rational Requisite Pro. We used mostly waterfall methodology and both tools were quite good with it. Unfortunately, they are obsolete now and not supported anymore. When a couple of years ago I had to write the requirements again, I was really surprised. Now Confluence and Jira are used everywhere, absolutely everywhere. Imagine my surprise because I know that Jira is an issue tracker and Confluence is a corporate wiki. Can you use an issue tracker or wiki for requirements management? Yes, sure you can, but I can hammer nails with a microscope as well. I believe this popularity of Atlassian products is mostly because of popular agile methodologies like Scrum and Kanban. In the past couple of years, I was working for a couple of companies and have seen same problems of applying Jira and Confluence the wrong way. Let us talk about some of those problems. Have a look on the screen, please. This is an example of Jira issue which is quite typical for most of the projects. Just bear in mind that I have sanitized the text a bit and transferred it into my own Jira so that I will not violate the NDAs I have signed. What we see here? A decent title, this is just fine. Oh, we have a description, cool! The developer will not chase the analyst or a product owner to get some details and explanations. I'd say these are the only positive sides of this ticket. Let us see the dark sides. First and most clear problem is that when this ticket will be implemented, closed and forgotten, no one ever will be able to learn why we have those names like yes and no. The ticket will be buried between thousands of similar tickets with no possibility to find the needed one. Have you ever tried to investigate an old system using just Jira? If yes, probably you could be a good archaeologist as well. Again, when this ticket will be implemented, the system will come to a new consistent state, but no one will know what is this state and why is it like this. Second point is that when the manager was writing the ticket, he has not analyzed the impact of this change on the other parts of the system. As a result of implementing this feature, a set of screens are now using yes and no, and the rest are still using true and false. This doesn't mean that the system is broken. I would call it just inconsistent. Third point about this ticket is that it is too vague. This results in different understanding of the functionality by different people, the developer, manager, QA engineer. Okay, let's look at one more ticket. It contains more detailed functional requirements. Developer is happy. The analyst has written a user story and even listed predefined periods for the events. But I know something about this ticket. The requirement was firstly written in Confluence, including this feature described by this user story. The manager has just copy-pasted some text from the Confluence description into this Jira ticket. And please just don't tell me that in your company this never happens. No one is insured from this kind of Jira tickets, just because it is so easy to make them. The main problem of this approach is obvious for any developer. What if at some point of time the requirements in Confluence and the description in this Jira ticket will start differ? where will be the correct description. So the Jira ticket and Confluence page will become out of sync. Next kind of desynchronization may occur when the customer comes to discuss this ticket and puts his valuable comments, which may contradict both Jira ticket and Confluence page. Now we have the third source of truth. And if we are lucky, the developer has read the Confluence page, Jira ticket and all the comments. But it does not mean that all the stakeholders has done the same. Okay, let me summarize this point. Jira is used to store the requirements. Even at Atlassian, they consider storing requirements in Jira as a good practice. But this leads to the following problems. If the requirement is stored only in the Jira ticket, then when it's done, the requirement is lost. If the requirement is stored both on Confluence page and in the Jira ticket as well, it might happen, and often happens, that they become out of sync. What we can do with this? First and obvious, just don't store the requirements in Jira tickets. This prevents us from losing the requirements when the ticket is done. Store the tasks for the team in Jira tickets instead of the requirements. Describe what your teammate should do, but not the system functions which he will be implementing. Next, never copy-paste the text from the Confluence. If you need to set a task for the developer, just paste a link to the corresponding Confluence page paragraph. Now let me show you a small example. Have a look here. This is a Confluence page containing detailed description of the use case administrator defines data template. It is detailed and fully describes everything the developer should implement. Just have in mind that it references some other requirements, such as forms descriptions. That's why no forms are shown here. Now, if we want to set a task for the developer, we have to literally write him implement this use case. As simple as this. You see, the Confluence page is the single source of truth. The requirement will not be lost when the ticket is closed, and all is up to date. Let's do it like this, and our documentation will not be lost in space and time. Next thing which bothers me is maintainability of the written requirements. Nothing is being changed more often than the requirements. There is no possibility to freeze them for a long period of time, so we need to deal somehow with this. The requirements are always interconnected and directly or indirectly impact each other. This is why it is so important to take into account the influence of the requirement on the other requirements when you edit it. Let me show you a small example. You see user story 1 refers form 1 and form 2. But form 2 is being referred from the user story 2 and user story 3 as well. If we are updating user story 1 and we need to fix the form 2, then how do we know that user story 2 and user story 3 are still correct after this fix? If we are doing such small ad hoc changes here and there, then how do we know that we haven't broken dependent requirements? The classical way to do this is to use the traceability matrix. I think everyone knows what is this. Have a look. On both axes I have placed all the requirements IDs. If the requirement 7 depends on the requirement 3, then I need to put a mark here, e.g. mark X. Sometimes the requirement may refer to itself, then we see a cyclic dependency. It is still okay. When the amount of requirements is relatively small, then the traceability matrix is quite easy to read, and it might even be useful for you. But when the amount of requirements grows, the matrix is becoming more and more difficult to read. I think most of you will hate such large traceability matrix. When it is large, it is really difficult to search for needed requirement dependencies, so readability is quite poor. And on the other hand, it is extremely difficult to support. Everyone literally hates to maintain this matrix. It is easy to make a mistake, and it is difficult to update it each time you make changes in the requirements. When I was a business analyst, Calibre RM supported us in building traceability easily. When you defined requirement B depending on requirement A, Calibre RM always showed us that A is linked to B as well as B to A. That was done automatically and with no other efforts required. This was really convenient to read because it really narrowed down the area of this traceability matrix just to one requirement and its connections. It is much easier to maintain. When you fix your requirement, you just go over the links and verify whether the connected requirements are still valid. In Confluence, theoretically, we also may build the list of the direct and reverse connections. Theoretically. On practice, what tools do we have here? A while ago, Confluence offered macros search results, which is not supported anymore. I need to say it was more or less close to what I usually mean when I say traceability. Now we may use third-party commercial tools. Some of them are relatively simple, some of them are quite large and offer full requirements management functionality like R4G. Anyway, I bet you will never use them to make just traceability because what we need here is something really simple. Something with one click of mouse, or better, with no clicks. This is why I have never seen good traceability made for requirements written in Confluence. This is what I want. As simple as this, automatically. One more pain point is how to measure the impact of the change request. For instance, you need to estimate how much effort you need to make changes in the requirements. Without a traceability matrix in any of its form, there is no other way than just thoroughly investigate requirements one by one and search for the possible impact. No one usually does that, right? That is too difficult. And what is even more difficult is to estimate full cost of the change request, including the development. When it comes to such estimation, the sales manager asks the team lead to estimate. The team lead delegates it to the developer. The developer tries to reckon how much it took to implement similar change requests last time, reckons all his fails and missed deadlines, and multiplies this estimate by 2, and then passes this number to the team lead. The team lead, in its turn, then reckons all his fails and missed deadlines, reckons all the nervous conversations with his boss and the customer, reckons all the nights when he could not fall asleep, and also multiplies this estimate by 2. This number is then passed to the sales manager. The sales manager also reckons how developers missed all the deadlines and how he was persuading customer that this is the last time, next time will be perfect, in time and budget, and also multiplies this estimation by 2. I think you see the tendency. When no one knows how to estimate the change request, this is the working formula. Here E is the efforts amount, M original estimate, N is the number of people in the chain between the developer and the customer. As a result, even first already incorrect estimate is multiplied so many times that the customer might refuse to pay such enormous numbers. To make long story short, if anyone from Atlassian is here, please give us some obvious and easy to use tools to make a traceability. One more problem which is difficult to solve with Confluence is branch management. We know multiple styles of branch management, trunk-based, Git flow, GitHub flow, GitLab flow, and all the other customizations. We have that many branch management styles because all the projects are different, all the companies and teams are different. It's quite important for each particular version of the application to have a corresponding version of the documentation. If the documentation is being maintained, then it should evolve totally the same way as the source code. Have a look. This is the main system branch. We have a documentation which corresponds to it and being actively maintained, this one. And these are the couple of older versions which are being actively used in production by different customers. What is true for version 1.1 is wrong for version 1.2 and is already obsolete in the main branch. When it comes to supporting these versions, the documentation already does not reflect this, right? I think you may agree that this is the correct way to manage the documentation the same way as we manage the source code. What Confluence may offer to us according branch management? Unfortunately, we can't have even trunk-based style. Each page lives its own life in its own trunk. There is no easy way to do branch management. We cannot freeze a set of related pages, we cannot fork a set of related pages, and we cannot publish a set of related pages. You know why, I guess? because Confluence is a wiki engine, not a requirements management tool. So what can we do when we really need some branch management for documentation? Don't use Confluence if this is an option, use GitLab. If you must use Confluence, try collecting all the related requirements on one single page. This way you may get at least trunk-based branch management. Unfortunately, you lose ease of requirements reusing if some other page needs to refer some other requirements on this mega page. I would mention a couple of other things which I would appreciate to see in Confluence, apart from traceability and branch management. I think normal traceability is not enough. I believe we may automate it a bit and check that if we refer to some requirement, then it exists at least. I would like to have some automation when create tasks on the new versions of the specification. For instance, if there is some difference in two versions of a UI form, then the tool should automatically create a task for a developer to implement this difference, a task for a QA to test it. Normal branch management might also be not enough. How about publishing requirements with a specific state, for instance, only those which are already approved, or only those which relate to some specific feature? Now let me show you how I see a documentation support tool in action. Now, in this part of my talk, I'm gonna show you how I see more or less simplified flow of working with the documentation. Let's imagine we need to develop a CV management system. I think each outsourcing company in IT has its own version of it, manual or automatic, whatever. The business goal for it is the following. When the customer comes and offers a project, the company needs to show him the team which will be working on this project. Obviously, the CVs which are shown to the customer should be in one format containing similar sections and be of similar appearance. This might be done manually by team members or HR certainly, and also we may collect all the needed data about the team members and export it in required format with the corporate appearance standards. So let me start working on the requirements for the CV management system. I want to firstly write some business requirements, which is a starting point for our system. This is what I want to do. I want to implement a CV management system. I write the requirement in Markdown format so that it is easy to view and edit as well in any text editor or any system. Markdown is probably the simplest formatting language which suits our needs. Okay, let me open this. Okay, so let me add this requirement. Implement a system which allows the user to create, update a CV. We need not only to help the user providing some template, but also propose same defaults for each technological stack and any level of seniority. Next, each requirement should be unique and atomic, so I want an ID for it. This is what I'm doing. I'm defining ID for requirement. I know that this tag def is not part of Markdown standard. This is just for me, so that I personally will know the ID of this requirement. Next thing which I want to know is a couple of requirement attributes. Okay, let me add those so that I will know the status of the requirement and who is responsible for it. Good. In the same manner, I'm adding a couple of more high-level requirements. You see this one for upload templates and this one for managing users. Maybe these are not all of them, but for this talk I think it's enough. You see that what I want to get is to upload the appearance templates and manage users. Of course, creating CVs as well. Next, in the same manner, I'm going to add some properties of the document. You see, this is the title of the document, the type, and the version. Probably we will need those further. Okay, let me save this document. This document will be my starting point. Next, what I want is to create a directory for my functional requirements. This is the place where I will put my user stories, use cases, forms descriptions, and maybe something else. Similarly to the previous document, I'm gonna put some requirements to it. And then I'll start with the very first use case, which I call administrator defines a data template. Okay, this is my new document, and this is the very first use case, administrator defines data template. I'm not going to dive into the details of this flow. You see, it's quite a large case. So I just want to mention that it is of main importance for us. That is why I'm working on it first. How do I know that? Oh, this is the business requirement, which it is implementing. You see, this one. I'm referring to these requirements from this use case using this simple notation, this ref tag. Since I know that the business requirement which is most important, I'm going to write the use case for it first. What we have so far is a high-level business goal, a request from the customer, and we respond with the use case, with this one. But the use case is not fully described in the system, so we cannot pass it to the developers. Firstly, we need to add a forms description. For that, I'm gonna create a separate file and describe the dependent forms. Okay, now that I have finished adding requirements, these are the files that I have. I already shown you the business requirements and the use cases which I have written with you, and there are some more files. This is the UI forms descriptions. For instance, this is entities, glossaries, some messages localized, mockups. And have a look here. This is the UI forms descriptions. This is an example of a fifth form, so you can see this is quite straightforward. These are the elements descriptions. For example, this is the email and some of its properties. This is the password and a couple of buttons, for instance, sign up button, and the description and some constraints for this. So I think this is quite obvious how to read this. So let me show you the next. This is the diagram of all those requirements, starting from the business requirements, and each business requirements is being mapped by a couple of use cases. You see those, and each of the use case is implemented using a couple of forms. Some of the forms are used by more than one use case. For instance, this form is referenced by 4 use cases. This one is referenced by 2 use cases. So you see, some requirements are interconnected, and this is the traceability I really want to see, not the traceability matrix. Okay, as I have all those files, so let me push them into the Git repository. So what I'm going to do is I'm going to create a blank project, for instance, like this. Okay. Now this is what I'm going to do. Cool. So I have the first commit. Now I need to push it. Cool. Let me see. This is my first repository with the requirements. This is how GitLab shows them. Quite readable, I think. When I come to storing the requirements in Git, the first thing I hear from any manager is that the business analysts are not technical persons. This is too difficult for them. All those console tools are complex even for developers, so BAs will never use those. Okay, then let me agree with you and show you what GitLab can do for you. For instance, we have the requirements for entities. It is a quite simple description. Let me show you. You see, I have just one requirement for the user. I have 3 states: inactive, active, and suspended. For instance, what we can do if we need to add the 4th state, for instance, validated. I can open this file with the web IDE. You see, this is being shown in a very pretty manner. You can open any file and see it as in normal IDE, like this. And we can update it, for instance, like this. Okay, I'm gonna commit this. It shows me in which branch I want to commit. I can, of course, start a new branch, but let me, for this talk, do the simplest possible way. I'm gonna commit to the master branch. Okay, cool. You see, I can use Git without all those console tools, and if it comes to updating those requirements by BAs, then we can just allow them editing the requirements from the web IDE of the GitLab, you see. And when we have those commits, then you know what we can do here. We can start discussing them. I'm not reinventing the wheel. You see what I'm doing here is I'm using the same tools for requirements or documentation management, totally the same tools as we use for code management. And I think this is quite good idea. Now, as I have all the requirements I want for my first iteration, I'm going to build a document. I have a lot of interconnected files which are still quite difficult to read. I want to have working references forward and backward for traceability. And I want this document in different formats so that I can send it via email as a PDF or publish it as a HTML or show it as a pure markdown. So let me show you what I have here. Here is a target directory, and this is the template for my future LaTeX file. It does not contain any requirements. It does contains only the reference to the future document, this one. And here, these are the couple of includes here. So, okay, this script runs rqs.jar. This one is a small tool which I have written in a couple of spare evenings for my personal needs. This is not an advertisement. I'm not trying to sell this tool or start an open source project because it is not published anywhere. This is just my small toy, but it may do some useful things for us. Okay, let me run it. Good, let me show you what it has created. This is the concatenated document which contains all those requirements files. It is not just concatenated, it has some processings. Let me show you this a little bit further. Now what I'm going to do is to convert this document into HTML and LaTeX. I can do this with the pandoc tool. You see, this converts with pandoc from Markdown to HTML, and this one from Markdown to LaTeX. Okay, I'm converting to HTML, and then also I'm converting to LaTeX. Okay, good. So this is the HTML document. It doesn't have any styles, so I will not show it right now. And this is the LaTeX stub. Now I need to convert it into PDF. Okay, I think it's ready. This file contains all the requirements in PDF format. I think it looks quite beautiful. It has all the things which we are expecting from a large and enterprisey document. You see, this is a title page. It contains the contents, and these are the business requirements which I have written. And please have a look. It has backward traceability. It shows us in which use cases this requirement is being used. For instance, the business requirement 1 is implemented using the use case 8, and all those references are working. We can go forward and backward. You see, this use case originates from business requirement 1. For instance, business requirement 2 is implemented by 4 use cases. Have a look. Cool. Here we have the interface descriptions in some tables. Okay. And also let me show you how it converts the references. For instance, this is the 8th use case. Let me show you how it looks in the source code. This is the 8th use case. You see what I'm doing? I'm referencing the 6th form. I'm referencing a button in the 7th form. For instance, I'm referencing the form 7 and button A.01, right? And also I'm referencing a form, and you see the idea. I'm referencing all the UI elements by their IDs. I don't know how they're entitled, because although titles and captions, they may change from time to time, and I'm not going to change the use cases after that. So I use this tool to reference those requirements by their IDs, but when I have this document published, it automatically substitutes those IDs with the titles which those elements have. For instance, you see here, this is the 6th form. It is called sign in. This is the button which I was referencing from the 7th form. It is called export. This is the 8th form. So you see the principle, right? Again, as I have already built the document, I think you will tell me that this is too complex. We have a couple of console tools which are so hated by the business analysts. So let me help you with this a bit. So this is the project which I have in my Git, and this is Jenkins. Let me create a job which will build this document for you. Okay, so now I'm choosing Git. I need to use a repository, and I will use my credentials. Good. Now I'm gonna add some steps, and this will be a shell command. Or is it? This one. Okay. The first one will be building the document. The second and the third one will be converting this document in the desired formats. And the last one will be building the PDF. So let's hope it will work. Let me try starting it. I need a project file here, I think. Let me see whether this file is here. And while it is rebuilding the project, I will show you what is this file about. This file contains description of the build process. It says that all the requirements are in this current directory. It specifies where we want our output and the collection of files which we need to build. Should be good from the second time. Oh, cool, it's successfully built. And what we have here is the target directory with a couple of artifacts. This one is the PDF which we were building and which I have already shown you, with the business requirements, the use cases and whatever. Okay, sorry. This is the HTML document with all the working references. And we can also build it, publish it somewhere. And this is the markdown file. So, in this talk I have shown you how you may manage the requirements, functional or non-functional, using the same tools as you use for coding. You may use Git for branch management of your requirements, GitLab for working on them. You may use Jenkins to build the documentation along with the other artifacts. And with some programming done, you may get good traceability forward and backward, referencing named UI elements and checking that the referenced elements do exist. It is as simple as this. I hope my talk will motivate you to start using something except Confluence for the requirements management. In this case, at some point in the future, we will have normal command line tools for requirements management. Thanks for listening. Now I am open for questions.